9,261, 10,648, 12,167, 13,824, 15,625. And backwards. 15,625, 13,824, 12,197, 10,648, 961. And by hooks. 21 cubed is 9,261. 22 cubed is 10,648. 23 cubed is 12,197. 24 cubed is 13,824. 25 cubed is 15,625. And by digits, 9261, 10648. Again, 9261, 10648, 12167. 94. Try again. 9261, 10648, 12167, 13824, 13824. 961, 9261, 9261. 10,648, 10648, 10648, 10648. 12,167, 12167, 12167, 13,824, 13824, 13824, 13824. 15,625, 15625, 15625. 17,576, 17576, 17576. 19,683, 19683, 19683, 19683. 21,952, 21952, 21952, 21952. 24,389, 24389, 24389, 243. All right, so as said, I won't be practicing them infinitely, but we'll instead switch to geometric formulae. Hello. Okay, for a rectangle, that's fine. For a parallelogram, For an A by B rectangle, the perimeter is 2A at 2B. The area is AB. For a parallelogram, shorter side A, longer side B, focus angle theta, and height h. The area is BH, or AB sine theta. AB sine theta. And the perimeter is 2A plus 2B. For a triangle of altitude h and base B, half BH, we know that. Half AB sine C, we know that. For the area. Heron's formula. The square root of S times S minus A times S minus B times S minus C. Again, the square root of S times S minus A times S minus B times S minus C. And again, the square root of S times S minus A times S minus B times S minus C. And that's Heron's formula. Heron's formula. All right. Let's move back to computation now. Set 16. All right, so we have 2-digit numbers, single digits, A, B, and C, D. AB plus CD is 137. ADCB plus, let's do it again. B, C, and D are single digits. So AB is a 2-digit number, where A is the first digit, B is the second digit. All right. AB plus CD is 137. And hence find ADCB plus CBAD. Okay. All right. ADCB plus CBAD. All right, so there are some things we can say about them. Okay, so it must be in excess of 1. Are we to assume that there are distinct digits? Maybe. Well, you can just find a combination that works. Okay. Like, let's say 41 and 96, right? It seems to be an underdetermined problem. All right, then I'll come back to it. Five consecutive integers sum to 10 to the 2018. Find the median. Okay. Now, the median, five consecutive integers could be modeled as x minus 1, x minus 2, x, and then x plus 1, x plus 2. And so the median is x, and their total is 5x. And 5x is 10 to the 2018. So their median is 10 to the 2018 divided by 5. Which is 2 to the 2018 times 5 to the 2017. But it's unclear if they would want something expressed any simpler than that. So you say to us that five consecutive integers sum to 10 to the 2018, and you ask us for the median, and we say 2 to the 2018 times 5 to the 2017. Positive integers a and b satisfy 2026 equals a to the b minus a times b, so find a plus b. All right. Okay, so we could factor out a, and then it becomes a to the b minus 1, or minus 1. So a times a to the b minus 1, or minus 1. we do a squared minus 2a, so it's a times a minus 2. And because it's so close to the square, oh, positive integers a and b satisfy 2026 equals a to the a squared minus 2a. So a times a minus 2. Forty-six times 44. Forty-six squared is 2,116. 46 times 2 is 92. So 2016 plus 8. 2024. Very close. That doesn't work. A to the b minus 1 minus b. I don't know for this one. Don't know either. How many distinct values do 2 plus 2, 2 minus 2, 2 times 2, 2 divided by 2, and 2 to the 2 yield? 2. Is that the right order? Yeah, that's the right order. How many distinct values do 2... How many distinct values do 2 plus 2, 2 minus 2, 2 times 2, 2 divided by 2, and 2 to the 2 yield? We go through them one by one. 4, 0, 4, 1, and 4. That's 3 distinct values, 0, 1, and 4. That's going to annoy me if it's there. Distinct digits K and L satisfy JKL plus JLL plus JLL. Rather, distinct digits J, K, and L satisfy JKL plus JLL plus JKL equals 479. So find J plus K plus L. J must be 1. It's the only way that we could ever get 479 from that. If it was 2, that'd be too high. If it was 0, that's not possible. So J must be 1. We've added 3 L's together and we get 9. The only way that's possible is if L is 3. So J is 1 and L is 3. So we have 1K3 plus 1K3 plus 133 plus 1K3. Now we take away 133 from 479 and we get 346. We halve it and we get 173. And so K must be 7. And so their sum is 11. So you say to us, if J, K, and L stand for digits, and JKL plus JLL plus JKL equals 479, what is J plus K plus L? And we say to you, it's 11. If 20% of 30% of X is 3 less than 30% of 40% of X, find X. 20% of 30% is 6%. 30% of 40% is 12%. So 6% of X is 3 less than 12% of X. So 6% must stand for 3. And if 6% of X is 3, if 6% of X is 3, then 100% of X must be 50. So X is 50. So you say to us 20% of 30% of X is 3 less than 30% of 40% of X. So what is X? And we say X is 50. Which is closest to 1? 0.95 squared, 1.05 squared, 0.96, 1.04, or 0.95 to the 9. which is closest to 1 squared, 0.96, 1.04, or 0.95 to the 9. We dismiss the fifth one as that will be smaller than anything there. 0.95 squared versus 1.05 squared. We believe it's one of those two. However, 0.95 squared is 0.9025, so that one clearly fails compared to the third and fourth options. 1.05 squared likewise is 1.1025, so that fails for the same reason. So out of 0.96 and 1.04, both of them. So you ask us which of these is closest to 1, and you say 0.95 squared, 1.05 squared, 0.96, 1.04, and 0.95 to the 9. And we say it's the third and fourth options who said 0.96 and 1.04. How many distinct sums can be rolled with 3 standard dice? The lowest sum is 18. So it's all the numbers from 3 to 18. From 3 to 18. Now, it's tempting to say that that's 15, but that's wrong. Because remember, to count from 3, 4, 5 all the way up to 18, what you actually have to do is upper bound minus lower bound plus 1. So it's 16. So you ask us, how many distinct sums can be produced by the roll of 3 standard dice? And we say 16. Alright, there's just a little bit too much noise for me to hold all of that, so I'll have to do it internally. Which of 2 times 0 plus 26, 2 plus 0 plus 2 times 6, 20 plus 26, 20 times 2 take 6, and 20 plus 2 times 6 is the largest. So we have to go through them one by one. First is 26, second is 14, third is 46, fourth is 34, and last is 32. So the largest is the third one. Which of 6 plus 5 plus 4 or 6 plus 5 minus 4 or 6 plus 5 times 4 or 6 times 6 minus 5 times 4 or 6 times 5 divided by 4 is the largest? No is closest to 0. Darn it. Which of 6 plus 5 plus 4, 6 or 6 plus 5 minus 4, or 6 plus 5 times 4, or 6 minus 5 times 4, or 6 times 5 divided by 4 is closest to 0? We go through them one by one. The first is 15. The second is 7. The third is 26. 15, 7, and 26. Closest we have so far is the second one. The fourth is negative 14. And the fifth is 7.5. So now we go backwards. So 7.5, negative 15, 26, 7, and 15. The closest out of all those was actually the second one, which is 6 plus 5 minus 4. That's the closest to 0. Alright, so the ones done were fine. Set 17. We need a new piece of paper for that. Three children's ages, sum to 31. Find the sum of their ages in 3 years. So it will be 40, because each child is 3 years older, and thus the whole set is 9 years older. So 40. So you said three children's ages, sum to 31, and to find the sum of their ages in 3 years, and we say 40. How many two-digit squares differ by 1 from a multiple of 10? There's only a few to check, so we can go through them one by one. 4 doesn't work, nor 5, nor 6, but 7 does. 8 doesn't work, but 9 does. So there's only 2 of them, namely 7 squared and 9 squared. You asked us how many 2-digit squares differ from a multiple of 10 by exactly 1, and we say 2. Which of 5, 7, 8, 9, 10 is not a difference of 2 squares? Okay. Now, we know that 5, 7, and 9 work. 5 is the difference between 2 squared and 3 squared. 7 is the difference between 3 squared and 4 squared. And 9 is the difference between 4 squared and 5 squared. As for 8 and 10, the thing is, 2 squared and 4 squared differ by 12. And 4 squared and 6 squared differ by even more. It's it's 8 and 10. We think it's 8 and 10. You ask us which of 5, 7, 8, 9, and 10 is not the difference of 2 squares, and we think it's 8 and 10. But a crew digs 5 meters of tunnel per day. How many days to dig 2 kilometers of tunnel? 1,000 meters per kilometer. So after, I'm sorry, we dropped it. Was it 2 kilometers, you said? Yes, it was. Okay, a crew digs 5 meters of tunnel per day. How many days until they dig 2 kilometers? As we were saying, 1,000 meters per kilometer. So 200 days to dig a kilometer. So 400 days to dig 2 kilometers, which is just over 1 year and 1 month. You say to us a crew digs 5 meters of tunnel per day, and how long to dig a tunnel of 2 kilometers in length, and we say 400 days. Which is true? 4 over 1 equals 1.4. 5 over 2 equals 2.5. 6 over 3 equals 3.6. 7 over 4 equals 4.7. Or 8 over 5 equals 5.8. Which of those is true? The first one is blatantly false, as 4 over 1 is 4. The second one is true because 5 over 2 is 2.5. The third claim is false because 6 over 3 is 2. The fourth claim is false because that would be 3.75, not 4.7. And the last claim is false because that's 1.6, not 5.8. So it's the second claim that you made. 5 over 2 is 2.5. You asked us which of the following is true. 4 over 1 equals 1.4, 5 over 2 equals 2.5, 6 over 3 equals 3.6, 7 over 4 equals 4.7, or 8 over 5 equals 5.8. And we say the second claim is the only one that's true. 5 over 2 equals 2.5. Distinct digits. Distinct digits satisfying KAN plus GA equals ROO, and hence find RN take KG. It's kind of too late for me to be doing that one. I'll have to come back to it. Sure do wish that noise would stop being made outside my place. How many of the following are not prime? 1 squared or 2 squared, or 2 squared or 3 squared, or 3 squared or 4 squared, or 4 squared or 5 squared, or 5 squared or 6 squared? How many of those are not prime? 1 squared or 2 squared is 5. 2 squared or 3 squared is 13. 3 squared or 4 squared is 25, famously. 4 squared at 5 squared is 41. And 5 squared at 6 squared is 61. So all are prime, but the middle the middle sum, 3 squared and 4 squared. And you ask us how many are not prime, so we would say just the middle one. You ask us how many of the following are not prime, 1 squared or 1 squared or 2 squared or 2 squared or 3 squared or 3 squared or 4 squared or 5 or 4 squared or 5 squared or 5 squared or 6 squared, and we say just the middle one, 3 squared or 4 squared. That one's the only one that's not prime. Which of 4, 9, 16, 25, 36 is... We're just going to do a few more now, and then we have to stop, all right? Which of 4, 9, 16, 25, 36 is the sum of 2 consecutive cubes? Okay. Right, because they're consecutive, we dismiss the negatives immediately. 0 and 1 we dismiss. 1 and 8 makes 9. 8 and 27 makes 35. 27 and 64 makes 91. And all the others exceed. So the answer is simply 9. 9 is 1 cubed or 2 cubed. So you ask us which of the following is the sum of 2 cubes, 4, 9, 16, 25, 36, and we say only one of them, 9. I'm not doing a digit problem currently. This is the last one now. If 0 is less than p, which is less than q, which is less than 1, which of the following is the largest? Q take p, or p take q, or p add q over 2, or p over q, or q over p. All right. So you ask us which is the largest. Well, we can straight away dismiss p minus q, the second one, because that would be negative. Q minus p would be larger than that. Q add p over 2 would be bang in the middle of them. It's actually going to be q over p, because that would be greater than 1. The q over p. And q over p was Q over P was the last option you said. So you ask us which of the following is the largest, given that 0 is less than P, is less than Q, and is less than 1. Q minus P or P minus Q, or P plus Q over 2, or P over Q or Q over P, and we say Q over P, as it's greater than 1. But as said,